Let's go ahead and take a look at 3 homework problems from 3.1, 3.3 online. You might be struggling with these because we didn't get a chance to fully go over the 3.2 section in class today. So hopefully this should help some of you guys. And so in this first question on number 19, you're asked to calculate the grouped mean and standard deviation. We barely introduced that today, so I'm show you how to do it. So the group mean, because this is group data, it's not a long list. You're going to, of course, open up StatCrunch. When you open up StatCrunch, the data comes in. With that data in, we can now go ahead and calculate the grouped mean. And so you would go there, stat. Let me open that up a little bit more. You go stat, summary stats grouped or bin data. And on this case, the data again is binned into the temperature. And then the days has the count. And this is where, again, you might have a different type of problem, but that's what you would do. Compute. What are we going to compute? The mean. And on this problem, it says approximate the mean and standard deviation for temperature. Treat the data as a population. That's important right there. And so that's where we barely start introducing those ideas of the different standard deviations. So in this case, you wouldn't choose this option. You would go ahead and choose this unadjusted standard deviation. This is for population. This is what you have for population. So those would be what you choose to get your computations with. And so those are the numbers that you're going to put in here. So for example, let's get back to that. You have the, I see 79.49, round to 1 decimal place, so 79.5 would go here. And so I could go ahead and check my answer. There we go. What's the population standard deviation? That's that sigma there. And so then we could go back and take a look at that there. That's 7.78, 1 decimal place. So that's 7.8. Check that answer, and we got it. So that's how you can get those values, the unadjusted standard deviation. This looks is bell-shaped, so we're good there. Check. And so then this question here, C, we didn't get to in the lecture, so this is going to be hard to understand in class. But what you're doing is the 95% rule says that 95% of the data that you see here, 95% of the data would be 2 standard deviations away from the average. And so what you're going to see on this problem, what you would do is you would take 79.5 and then you would add 7.8 to it twice. So what we're going to do in terms of the calculation here, what you would do is, let me get a calculator open. There it is there. In terms of the calculations to get that bottom number, 79.5 minus, you're going to do 2 times 7.8. And so you end up with, that's the wrong this is a messed up calculator here. So you're going to do 79.5 minus 7.8, but we want to do that twice. Minus 7.8. And so then you get 63.9 here. Here on this section here, you're going to end up doing 79.5 plus 7.8 plus 7.8. And the rule is 95%. Rule says that's the idea of 2 standard deviations. 95.1 goes there, and so that's what you end up with there. And so that's what you were doing. We'll talk more about that on Thursday. And the other question was 22, and 22 and 23. Your first class in the frequency table 0 to 4, seconds 5, 9. What's the class midpoint? The midpoint is going to be 2.5. That's what our answer would be there. Now, how do I get that? The 2.5, that's 22 and 23. Again, this one's 23. The class midpoint's going to be 2.5 again. What we're looking at is we look at the lower class limits. The class width for that is 5 minus 0. And then the midpoint is half of that. And so that's where you get the 2.5 from. It's not going to be 2, but 2.5. The class midpoint, the class width is 5, and then half of that is 2.5. So that's where you would get the class midpoint to be 2.5 for the first frequency. The class midpoint for the next one would have been 7.5. Check my answer. That's it for 19, 22, and 23.